Hi, and welcome back to Math with Sophia, a part of Sola Math. Find more math resources at solamath.com. In this video, we'll be covering factoring quadratics. So we'll go over how to factor different kinds of quadratics, such as ones where the leading coefficient is 1, or where the leading coefficient is greater than 1, and how to use the different methods to factor the different kinds of quadratics. So for this one, for example, we will use the sum product method. For this kind here, we'll use the grouping method. And the third expression on here is a difference of squares. So let's get started with some examples. First, we'll go over one of the most basic methods to factor a quadratic, which is the greatest common factor. So if we look at our example here, in order to factor this, we just look at both terms and figure out what the greatest number and variable we can factor out of both of them is. So I see that I can factor a 2 and an x out of this, and a 2 and an x out of this second term here. So that means we'll take the 2x and put it out front of parentheses. And if we factor 2x out of 2x squared, so we're basically dividing, then we'll be left with x, and we can double check by multiplying it back. 2x times x will give us 2x squared. And now if we factor a 2x out of 8x, we're dividing again. So 8x divided by 2x is 4. So we'll be left with a positive 4. And again, we can multiply back to double check. 2x times 4 will give us 8x. Let's try another example. 3x squared minus 5x. So let's see, what do these both have in common? Well, a 3 and a 5 don't have a common factor, but both of these terms do have an x. So that means I can factor an x out, which means we'll be left with 3x squared divided by x is 3x, and negative 5x divided by x is negative 5. And we can double check by multiplying this back in. X times 3x is 3x squared, and x times negative 5 is negative 5x. Let's try another example. 6x squared plus 12x. So both of these are divisible by 6, and they both have an x. It's divisible by 6, and there's an x. So we'll take out the 6x and put a parentheses. 6x squared divided by 6x is x, and 12x divided by 6x is positive 2. And we can multiply it to double check. 6x times x is 6x squared. 6x times 2 is 12x. And that is factoring using the GCF. And this is an important method because sometimes we use this along with other methods. So now we're going to focus on factoring quadratics that have a equals 1. So a equals 1 means this first, the leading coefficient, is 1. That's what the a represents. So to do this, we're going to use the sum product method. Before we get started on the sum product method, it's helpful to draw out what this factored form is going to take. So when we factor this quadratic, it's going to end up being two groups with x in the front. Because when we multiply it back out, we're going to start with x times x, and that has to give us x squared. So that's why we know it's going to take this form. Now we need to figure out what goes here, what two numbers go in these spots. To do that, we look at this value and this value. we need to find two numbers that add up to -5. So their sum has to equal -5 and multiply to be -14. So their product has to equal -14. It's easiest to start with a product. So two numbers that multiply to give us 14 are 7 and 2. But since we need it to be negative, we'll have to make one of them negative. So let's try 7 and -2. 7 plus -2 equals 5. 7 times -2 equals -14. So this works for the product, but not for the sum, because we got 5 and we need -5. So let's try -7 and +2. -7 plus 2 equals -5. -7 times 2 equals -14. So these two numbers do work. So now we know what values to put in here, and that will be -7 and +2. And that is our factored form of x squared minus 5x minus 14. And we can always double check by multiplying these back out and simplifying. Let's try another example. X squared plus 3x minus 18. So we can go ahead and write the form that we know it's going to take, two groups with an x at the front of each. And that's what we can always expect when the a equals 1, when the leading coefficient is 1. Now we need two numbers that will add to be 3. So their sum equals 3, and that will multiply to be 18. So the product equals -18. Well, we know 6 and 3 equal 18, and one of them has to be negative. So -3 plus 6 equals 3, and -3 times 6 equals -18. So these two numbers work. And now we know what to plug in these spots. -3 and +6. And that is the factored form of x squared plus 3x minus 18. Let's try two more examples. So here we have 2x squared plus 14x plus 24. And we're factoring quadratics. Here it says with a equal to 1, but our leading coefficient here is 2. So sometimes we need to look at our entire quadratic and see if there's a greatest common factor, or a GCF, that we can factor out of the entire thing before we use another method. And in this case, I noticed that they're all divisible by 2. So we can factor out a 2. So we'll put a 2 out front. And what we're left with is 2x squared divided by 2 is x squared. 14x divided by 2 is 7x. And 24 divided by 2 is 12. So now we're looking at a quadratic that does have a leading coefficient of 1. Now all we're factoring is x squared plus 7x plus 12. And we will just bring down this 2. So we know our factored form is going to look like 2 we bring down, and then we do our two groups with x in the front. So we need to find two numbers that add up to 7 and multiply to equal 12. So their sum will equal 7, and their product equal 12. Two possibilities that come to mind to give us 12 are 6 times 2 and 3 times 4. Let's go with 3 and 4. 3 plus 4 equals 7, and 3 times 4 equals 12. So these work. So in our parentheses, we will have positive 3 and positive 4. So that is our final answer. 2x squared plus 14x plus 24 factors into 2 times x plus 3 times x plus 4. Now let's look at one more example that's a little different so that you notice that not all quadratics are factorable. Let's look at x squared minus 7x plus 5. So if we try to use our sum product method, that means we need two numbers that add up to negative 7 and multiply to be 5, positive 5. But the only two factors of positive 5 are 5 and 1. But 5 plus 1 will equal 6. There's no way we can get 5 and 1 to add up to negative 7. So this won't work, which means this quadratic is not factorable. All right, let's move on to difference of squares. Difference of squares is a method that is exactly what it sounds like, where there are two perfect squares and one is being subtracted from the other. So x squared is a perfect square. Its factors are x, and 49 is a perfect square. Its factors are 7 and 7. So we'll draw our parentheses, and in the front of each group, we'll put the factors of x squared, so x and x. And the second term of each group will be the factors of 49, so 7 and 7. And these middle values will just be positive and a negative, because the 7s have to multiply to give us a negative 49. So that means one needs to be positive and one needs to be negative. So when we're given a difference of squares as our quadratic, it's a very straightforward quadratic to factor. Let's look at another example. X squared minus 81. So again, we have two perfect squares with a subtraction in the middle. Keep in mind we can only use this method when it's a difference. So there has to be a minus sign in between them for this to work. So we'll write two groups, and in the front goes the x, and in the back is plus 9 and minus 9. Let's do one more example. 3x squared minus 75. So if you notice, this is not a perfect square. This 3 is not a perfect square. But both terms are divisible by 3, so we can factor out a 3. So we'll get 3 times x squared minus 25. And now we have a difference of two squares. So we'll bring down our 3 and put our parentheses. This perfect square is a product of 5s, so it's going to be x plus 5 times x minus 5. And that is the difference of squares. And now let's go to our last method. Our last method is factoring by grouping, and this is useful when our leading coefficient is greater than 1. So here our leading coefficient is 2, and we can't factor that out of this whole expression. So we're going to have to factor this whole thing. Factoring by grouping requires us to split this middle term up into two separate terms. First, we're going to bring down the first term, 2x squared, and the last term, positive 21. We're going to leave space for two terms in the middle that we split this 17x up into. So these terms will have to add up to 17. So their sum will equal 17. And their product is going to be the product of 2 times 21. So we're not just looking at this value anymore. We have to multiply the first and the last coefficient to get what we need for the product. So the product is going to be 2 times 21, which equals 42. So a few possibilities come to mind. 2 and 21. There's 6 and 7. There's 14 and 3. Now we need to check and see which one of these adds to be 17. 2 plus 21 would be 23. 6 plus 7 would give us 13. 14 plus 3 will give us 17. So our two values are going to be 14 and 3. So now we know what to put in these two spots. Positive 14 and positive 3. And we can't forget our x. X and x. Now this is when we use our GCF. What we're going to do is group the first two terms and the second two terms and factor GCF out of both groups. So 2x squared plus 14x in one group plus 3x plus 21 in another group. Now we find the greatest common factor of this group. Both of them have a 2 and an x we can factor out. So that'll be 2x times, and in the middle we'll be left with x and positive 7, because 2x times x is 2x squared, and 2x times 7 is 14x, plus, I can factor, both of these are divisible by 3. So I can factor a 3 out of that group, and we're left with x plus 7. Now notice this group and this group are the same. They're both x plus 7. That means whenever that happens, we can take what's in front of each of them and put it in one group together. So the 2x and the positive 3, 2x plus 3 in one group, and x plus 7 in another group. And that is the factored form of 2x squared plus 17x plus 21. Let's try one more example. Let's look at 3x squared plus 11x plus 6. So whenever we have a coefficient in front here, the first thing we want to do is see if we can factor it out of the entire expression. In this case, we can't. So we're going to use factoring by grouping. So we'll bring down our 3x squared and our positive 6. And we need to figure out what two terms we can split up this 11x into. So we look at the middle term for our sum. We'll have to sum to equal 11. And we look at our first and last coefficients for our product. Our product has to equal 3 times 6, which equals 18. The first numbers that come to mind are 9 and 2. If we multiply them, we get 18, and if we add them, we get 11. So we know that we'll have positive 9 and positive 2, and bring down our x for both of these. So now we group our first two and last two terms. 3x squared plus 9x plus 2x plus 6. Remember to bring down that plus. We're not grouping them in multiplication yet. We are just putting parentheses around the first and last two terms. So now we need to factor out of each group, and I can see that both of these are divisible by 3 and x. So we'll take out a 3x from this group, and we're left with x and positive 3. And from this group, they're both divisible by 2. So positive 2 times x plus 3. Again, both of these groups are the same. So that means we can group 3x and positive 2 together. So we'll get 3x plus 2 in one group and x plus 3 in our other group. And that is our factored form of 3x squared plus 11x plus 6. And those are the different methods of factoring different kinds of quadratics. If you found this video helpful, hit the like button and subscribe for more.